So today we're going to talk about polynomial models in the real world. So this is where we take what we've been learning and apply it to real life situations. So we need to do some setup for our calculator in just a second, but first I want to remind you that polynomials will be different based on their degree. So a degree of 1 is linear, a degree of 2 is quadratic, sorry that got cut off. A degree of 3 is cubic, a degree of 4 is quartic. You have those in your notes so you can look and see the rest of them. But you can use these polynomial functions to model real world situations. So if you're ever doing an experiment in chemistry and you get a lot of data, you can record it and then put it in your graphing calculator and it will find an equation for that data. It's kind of actually pretty cool. So that's what we're going to do today. And the first stuff right here, all of this stuff, is just going to be setup stuff. So you will do these steps this one time, and then your calculator will be set up and you won't have to do this stuff again. Okay? So we're going to follow along with these directions. So first, obviously, turn your calculator on. And then we need to press the second button. That is the blue one. So press that. And then we're going to press catalog. That is 0. So press second 0. Then you're going to press and hold the down arrow for a long time until you see diagnostics on. So see diagnostics on. Put your little arrow next to that. Give me a thumbs up when you're there. Alright, press enter 2 times and your calculator screen should say done. Give me a thumbs up when that's done. Okay, so the rest of the setup for this stuff is that we need to also turn our plot 1 on. So press y equals. If it is not already, press the up arrow and enter, so plot 1 is highlighted. Your screen should look like mine. Give me a thumbs up when that's done. Okay, so that is a setup step. You don't need to do that ever again. Your calculator is now set up to do these problems, okay? So the first thing we're going to do is I've given us some data, and the first thing we're going to do is fix my mistake because I left one off. So write in 10, 1. So we actually have 5 ordered pairs instead of 4. And we are going to do what we did back when we did linear regression. We're going to enter this into L1 and L2. So I've given you directions right here. Enter data into L1 and L2. To do this, we are going to press stat. And then you are going to press enter for edit, and you'll enter your data one at a time, pressing enter after they're done. So press stat, then enter for edit. If you have stuff in there, remember you go up to the top, clear, back down. What button do you not push while you're up here? Delete. Do not press delete while you're up there. So up, clear, then back down it will be gone. Or if you have stuff in there on the data values, you can hit delete. But don't ever hit delete when you have the name highlighted. Okay, so what's going to go in my L1? Which values? 2, 4, 6, 8, and 10. Yeah? Then in my y values, I'm going to have 3, 2, 4, 5, and 1. Thumbs up when you're done. So that puts the data in and that tells the calculator this is what I'm going to look at. Then you can look at the scatter plot now if you would like to, and we're going to because we're going to draw it. So how do we do that? Zoom, and then you press number 9 for zoom stat. So you'll see this. I'm going to draw that in here. So looking at this, remember linear is a line. Does this data look like it's in a line? No. Remember quadratic is a parabola, so a U. Does this data look like it's in a U? No. Cubic is a squiggle. Does this data look like it's in a squiggle? And then quartic, we haven't talked about, but it's in kind of a W. So we'll look and see which one is the best one. Okay, so we are going to now use our calculator to determine which is the best fit. And we have to do that by checking all of these. We have to check linreg, quadreg, cubic reg, and quart reg. To do this, we press stat. You ready for that? Stat. Arrow it to the right for calc. And then see that all 4 of those are listed. Linreg, quadreg, cubic reg, and quart reg. So guess what we're going to do? All of them. You ready? Okay. Oh, I forgot to talk about this. So then when we do those, we need to write down our equations and their R squared value. The R squared value is called the correlation coefficient. And it tells us how close our data is to the given equation. Okay? We also need to round any of our equations or R squared values to 4 decimal places. Okay? 4 decimal places. And R squared value closest to 1 is the best fit. That regression equation is your answer. So if quad reg is closest to 1, then it's the answer. If cubic reg is closest to 1, then it's the answer. So unfortunately you have to check all 4 to look at your R squared value to tell you which one's the answer. So you ready? So grab your calculators, press stat, arrow 1 over to calc, and can we just go in order? Okay, so we will press number 4 for linreg. Then how do we make it, how do we make the calculator actually do it? Enter. Then what shows up is all of this data. Oh, if you have a yellow calculator or a new calculator, yours might show up that you have linreg and then it will have a whole bunch of other junk like this. We'll have a whole bunch of other junk, L1, L2, blah, blah, blah. You need to go down to calculate and then press enter, and then yours will show up, okay? So if you have one of the new calculators, you might have to scroll down to calculate, and I'm sorry I left those directions out. Okay, so this tells you your linear regression equation right here, ax plus b. So a, then down here it tells us what a is. A is negative 0.05. It has an x after it, and then b is 3.3. So we will have y equals negative 0.05x plus 3.3. And then we also need its R squared value. What's its R squared value?
0.01.
0.01. So is that very close to 1? No. So is this probably a good equation? No. That was probably not our answer. So then we go back into stat again, press stat again, arrow right to calc. We just did linreg. What do we need to do now? Quadreg. So either press the number 5 or arrow down to 5 and press enter. Once it's on our screen, what do? Press enter unless you have one of the newer calculators, and go down to calculate and then press enter. Now here again we have our A, B, but now we have a C. So give them, A is the coefficient of x squared, B is the coefficient of x, C does not have an x. So we're going to write down that equation. Y equals negative 0.125x squared plus 1.45x plus negative 0.2. And what's my r squared value? 0.36. So is that better or worse than linear? It's closer, but is it still probably my answer? Still 0.36, is that very good? No.
Wouldn't it be just minus 0.2?
Oh, yes, it could be. Either way is fine. Alright, now try cubic reg. So back on our calculator, what do we press? Stat, arrow right to calc, 6 for cubic reg, enter. Now notice, what do you have this time instead of A, B, and C? You have a D. So same thing, A is the coefficient of the highest degree, x squared. B is the coefficient of the next highest degree. C is the coefficient of the next highest degree. And since D is the last letter it gives us, that's going to be the constant. So write in that equation. And what did we say to round to? 4. So you're going to have to write small. I'm sorry, this line is so small. So negative 0.0833 x to the third plus 1.375 x squared minus 6.4167x plus 11. And my r squared value is 1. What does that tell you?
Probably.
That's probably the answer. But we don't know, we need to check our quartic reg. So stat, over to calc, quart reg, which is number 7. Get that one? Okay. Now, I personally had never seen this before until I did this one. Notice, what does it say that A is? 0. So if it says A is 0x to the 4th, what does that mean? There is no x to the 4th. So with no x to the 4th, this is really cubic. So it didn't give us a new equation, and I'm sorry I picked a bad example, but we now know that this one is the closest to 1, correct? So this is our answer. So in Math Excel, if it asks us to find it, then we would type in that equation. So let's write it in here. Okay, so this is 1, but why isn't this one our answer? Why isn't this bottom one our answer? Because, why? Because it's technically cubic, so it's really just this one in disguise. So we use the r squared value to determine the best fit, so which one's the closest to 1? This one is. So in this case, which one is the best? Cubic. So the best polynomial is the cubic. So on Math Excel, I would type this in as my answer. Okay. Now you can make the calculator graph that along with your scatter plot, but you have to kind of do it in a weird way. Okay. So to make the calculator put it in, you press stat, arrow over to calc, pick the one that was the best. So which one was the best? 6, cubic. Press enter, show this information again, and while this is on the screen, that has to be on the screen, then press y equals, bars, which is right next to clear. Number 5 for statistics. Arrow right 2 times for EQ and press enter. Then that transfers that equation into your y equals, and watch what happens when you hit graph. Then remember, if you need to, you can change your window to see more or less of that. So let's draw that guy in here. Yes, you can hit zoom 6 to fit for the size, as long as your plot 1 is still on. So there are some on Math Excel that ask you to draw the scatter plot, and there are some that ask you to do some other things. If you have issues with your calculator, feel free to come try and find me if I am not actively teaching. You can just stop by room 308 and ask me some questions. Okay? So flip it over. The next one we're going to, and one more thing. Sometimes Math Excel gives you these as ordered pairs. Sometimes it gives it to you in a table with the x's all in one column and the y's in another column. So you may have to you'll have to look and see which way it's giving it to you. Ordered pairs, the first number goes in L1, the second number goes in L2. In a table, all of the first column would go in L1, or all of the first row would go in L1. Okay, on the back. On the back, instead of making the graphic calculator give you the model, on this one they've already told you the model. So this is the model that's estimating the average annual growth rate of a country's population. And I want you to estimate it for 1960, 1988, and 2015, where, and this is important, X is the number of years since 1990. That's important. Okay, so we have, unfortunately, another setup, but we'll do this just now, and then you won't have to do this chunk anymore, so that is a setup. Grab your graphing calculator, doesn't matter what's on the screen, hit second, and then window. Window is right next to y equals, second and window. Make sure next to independent, it says ask, and next to dependent it says auto. If either one of those is not happening, use your arrow keys to get to the correct word and press enter to highlight it. Ignore everything else. All I care about is independent says ask and dependent says auto. Give me a thumbs up when your calculator's set up. Okay, so again, this is a step you do not have to do again. So let's read down here. To do this problem, we are going to press y equals. So press y equals, clear what we have in there, and we are going to type in this equation. So point, and then it has 5 zeros, point, 5 zeros, then 833, x to the third. Remember the x key is right next to the green alpha key. The to the button, to the is above the division sign, x to the third, plus 0.0021 x squared, minus 0.1903 x, plus 8.1424. Give me a thumbs up when you have that in your y equals. Once we have that in our y equals, you can look at the graph by pressing zoom, or by pressing, by just pressing graph, but I'm not going to, we don't need to. So what we need though is after our equation is in, we need to hit second and graph to get our table. So press second and graph. Again, you'll have an XY chart. This kind of looks like your L1, L2. If you have some numbers in there, you can clear them or you can leave them, it doesn't matter. So we need to enter, we will enter our X values, they'll show up here, and once we press enter, they'll show up here and give us our Y value. So let's figure out what we need to put in our X values. So the problem said that it is the years since 1900. So what do we have to do to the years before we know what X value to put in? Yep, subtract. We have to subtract 1900 from every year before we input it as our X value. So when I put in 1960, what X am I really putting in? 60. When I put in 1988, what X am I really putting in? 88. And when I put in 2015, what X am I really putting in? 115. Good. So go back to second graph, so your calculator screen looks like that. Type in 60, 88, and 115. And those are your answers. 6.0837, rounded to 4 decimal places if it gives it to you, and 26.699.
What'd you think?
Okay, any questions about how you do that? If your answers are not the same as mine, go back to y equals and make sure your equation is in there correctly. 90% of the time that is the issue, is that your equation has been typed in incorrectly. Okay? Alright, last thing. Last thing we have to talk about, because here's some vocab words that Math Excel is going to ask you about. When you have a model like this one, the one we were just doing was predicting growth rate. When you have a model and you are predicting y values outside the domain, that's called extrapolation. Estimating within the domain is called interpolation. Interpolation is going to be reliable. Extrapolation becomes less reliable as you move away from the data. So sorry this messed up, I don't know what I did, put too many something. But using the previous example, let's list a year that you would use extrapolation for. So extrapolation is going to be outside the domain. Alright. So domain, is that X values or Y values? X, good. So if I go back up to this, my X values, or things that I put in, were 1960, 1988, and 2015. So what are those? The X's are what? What is that measuring? Were they the growth rate or the years? The years. So these are years, right? So this is saying that X is the number of years since 1900. Since 1900. So that's what it has based, that's what this equation is based on, is data since 1900. So the interpolation, or what it's based on, is going to be the years since 1900. And we got that because it told us, right? It told us in the problem. So that would be 1900 until now, correct? So that would be inside our domain. So what are some years that would be outside our domain? Okay, so years when? Before 1900 or far in the future. Because that's not information that we have yet. Sorry, I did not have enough coffee, and now I'm spelling things wrong. So, yay, erasable pens, they spelled things right.